Hey everyone, and welcome. Today, we're going to talk about something that's, well, it's pretty much everywhere in your life, even if you don't realize it. I'm talking about starch. It's this hidden powerhouse, and we're about to explore the incredible journey of how we get it from a plant into all the products we use every day. So let me ask you something. What do your favorite snacks, the pills in your medicine cabinet, and even the paper in the book you're reading all have in common? It sounds like a bit of a riddle, right? But the answer is actually super simple. It's starch.
And we are talking about a ton of it. Just look at our biggest crops. A single grain of rice, that's about 70% starch. Corn and wheat, same deal, almost 70%. Even a humble potato is up to 20% starch. It's one of the most abundant things in nature. But, getting it out has always been the real challenge.
Okay, so let's get into it. For literally centuries, the only way we could get at this incredibly valuable starch was, well, it was basically brute force, just a purely mechanical and honestly pretty inefficient process. So take a look at this. This is the old school way, the traditional wet pathway. It's a really tough industrial process that uses huge amounts of energy and water. You're basically taking a plant and just putting it through a whole gauntlet of mechanical abuse to try and force that starch out. Let's break that down a bit. First, you're crushing the plants into a pulp. Then you have to run that pulp through all these sieves to get the fiber out. After that, you let the starch settle out in giant vats of water. That's called sedimentation. And then finally, you dry whatever's left. It's all about physical power. Crush, wash, separate, and do it all over again. And here is the real kicker with that whole brute force method. Up to 20% of the starch you could be getting is just lost. It gets washed away, trapped with all the fiber and waste. I mean, can you imagine losing a fifth of your final product every single time? For a long time, that was just the reality. Yeah, so losing a fifth of your yield, not exactly a great business plan. It was pretty clear that a new approach was desperately needed. So, how did science find a smarter, gentler way to unlock all that trapped starch? And this brings us to the hero of our story, enzymes. The best way to think of them is like microscopic biological keys. So instead of smashing the door down with a sledgehammer, these tiny enzymes can find the exact lock on a plant's cell wall and just gently open it up, letting all the starch granules inside come free. So how do they actually do it? Well, it's actually super elegant. See, these enzymes, they're specialists. They target very specific parts of the cell wall, things like pectin and cellulose, and they just dissolve them. This breaks down the whole structure from the inside out, freeing the starch without all that crazy mechanical force. And the result? You get way, way more out of it. Okay, so that all sounds pretty amazing, right? A biological key that unlocks more starch. But does it actually work? Let's get into the numbers, because this is where it gets really, really impressive. So, some research from back in 1994 showed that if you use just one type of enzyme, it's called pectinase, on ground-up cassava root, you could increase the amount of starch you recover by up to 16.4%. That's a huge jump. That's almost all of that 20% we were losing before. And they saw pretty much the same thing with another enzyme called cellulase. It boosted the recovery by over 16%. So, okay, you've got these two different microscopic keys, and they both work great on their own. But the real question is, what happens if you use them both at the same time? Well, the researchers themselves noticed something really fascinating. They found that when you put these two enzymes to work together, it wasn't just a simple 1 + 1 = 2 situation. No, it created this incredibly powerful synergistic effect. And get ready for this. This is the result. When they were used together, these enzymes increased the starch recovery by a mind-blowing 36% over the old method. I mean, this wasn't just a little improvement. This was a complete and total game changer. It proved, without a doubt, that biology could massively outperform brute force. But, the story isn't just about enzymes. It's really part of a much bigger shift in how we think about all kinds of industrial processes. It's a move towards smarter, more efficient, and way more sustainable technology. And this push for smarter tech isn't only about biology. It's happening with the machines too. For instance, take the sieves they use. The old school round sieves are kind of like the brute force method. They're cheap, but not super effective. The newer centrifugal sieves, though, they cost more, but man, their extraction rate and capacity are on another level. It's just another example of smarter engineering winning out.
And this all falls under this big umbrella of green technologies. Really, all that means is finding new ways to do things that are better for the planet and more efficient. It's all about getting more value from the resources we already have, which, is the whole point of a circular economy.
So why does all this matter? Well, the takeaways are huge. For industries, it means making more money. For the planet, it means less waste and using way less energy and water. And for all of us, it can actually mean getting a better quality product in the end. It's a win-win-win.
So let's wrap this all up with one last thought on where this kind of thinking might be headed next. And that really leaves us with a pretty big question, doesn't it? If we can get a 36% gain on a process we've been doing for centuries, just by applying some clever biology, what other old problems could be solved with new science? What other hidden treasures are locked away in the world all around us, just waiting for the right key?